In section 1.5, we talked about negative exponents and exponents that are zero. Now, if you're given a problem and there's a base that has a negative exponent, the first thing you want to do is draw a fraction bar. Okay? The base with a negative exponent goes on the bottom of the fraction bar. The exponent becomes positive. And if there's nothing else that's in the problem itself, a 1 goes on top of the fraction bar. If you're ever simplifying a problem where a 0 is the exponent to a base, the base raised to the 0 power simplifies to be 1. Okay? So if we look at number 1, I have a base. My base is 5, and 5 is being raised to the negative power. So the first thing I want to do is draw a fraction bar. Any base with a negative power gets put on the bottom of the fraction bar, and the exponent becomes positive. If there's nothing else involved in the problem, a 1 goes on top of your fraction bar. If you look at number 4, once again, I have a base which is negative 3 raised to a negative exponent. So when I see that negative exponent, the first thing I'm going to do is draw a fraction bar. The base with a negative exponent goes on the bottom. The exponent becomes positive. And if there's nothing else in the problem itself, a 1 goes on top. If you look at number 5, once again, I have a negative exponent. The base with the exponent goes on the bottom, and the exponent becomes positive. If there's nothing else in the problem itself, a 1 goes on top. And those are how you're going to leave your answer, because the directions say write each expression using a positive exponent. So all of those problems now have positive exponents. Now, if you look at the next set of directions, it says write each fraction as an expression using a negative exponent other than negative 1. So if you look at number 13, actually let's look at number 11. Okay, what you have to think in your head is, okay, well, let's work backwards. Let's pretend I simplified a problem and I had 1 over 3 to the 4th power as my answer. How can I work backwards to get what that problem was? So for example, if you look at number 5, if I gave you 1 over m to the 6, the answer that I'd be looking for is m to the negative 6. So what you want to do is you want to take your base and you want to change and make your exponent negative. That being said, if I gave you the problem 3 to the negative 4th power, in order to simplify it, you would write 1 over 3 to the 4th. If you look at number 15, you would want to first write the denominator of the fraction, or that 49, with an exponent. So what number raised to a power gives me 49? That would be 7 to the 2nd power. Once you rewrite your fraction, then you can write the base and bring the exponent up and make it negative. And lastly, in the last set of problems, it wants you to simplify, so you're using those rules. You always want to check for multiplication or division property first. So if we look at number 19, I notice that my bases are being multiplied, which means I'm going to add my exponents. When I add my exponents, my base stays the same. Negative 2 plus 7 gives me 5. This would be my final answer because there are no negative exponents left. If we jump to number 20, where are we at here? 23. Once again, this is a multiplying problem. So I have my bases, and I'm going to add their exponents. So a to the negative 2 plus negative 5, b to the 3 plus 1. When you go ahead and simplify that, you get a to the negative 7th power, b to the 4th power. I cannot leave my answer like this because there are negative exponents. So I'm going to, since I see a base with a negative exponent, draw myself a fraction bar. Anything with a negative exponent goes on the bottom of my fraction bar with the positive exponent. If it doesn't have a negative exponent, it goes on top of my fraction bar. And then lastly, I'll do number 27. If you look at 27, that's a division problem. So the first thing you want to do is simplify that fraction there. And you're going to subtract the exponents. 24 divided by negative 6 is negative 4. 3 minus 2 gives me 1. And you'll notice that there are no negative exponents there, so that would be my final answer.